All right, so in these last couple of examples, we're going to continue to be given some giant, big, messy statement, and it's going to be our goal to identify whether or not this really big statement is in fact a tautology, a contradiction, or neither, one of these contingent statements. So the last couple that we just got done looking at all happen to be tautologies, and that's actually what the first one we're going to look at is going to be as well. And then afterwards, we're going to see a couple different ones kind of come into focus. So this first one is going to say, use a truth table to determine if the following statement is a tautology, a contradiction, or neither. I did notice that I wrote the word true in there. This should say use a truth table to determine this thing. And you can see that is a relatively large statement. It's got this conditional part that says P implies Q. There's also an and, a not Q, and then that whole thing becomes a hypothesis for a giant big overall statement that also has a not P at the end. So like I said, there is kind of a lot of unpacking that has to happen when you're working with some of these things, but if you go step by step, they're actually pretty easy to work with. You just kind of got to keep your rows and columns all in line and kind of work from the inside out. So that's exactly what we're going to do in this case. I have kind of sketched out the process that we're going to go. I'm going to think about first trying to identify the truthfulness of that thing, and then I'm going to come and try to attack this not Q portion. Then I'm going to come and attack the overall hypothesis of that giant statement. I'm going to create a little column for the not P part, and then at the very end of the day, I'm going to look at the giant overall statement. So like I said, work from the inside out, try to just do little tiny pieces as you go. As you become more comfortable working with these things, you might be able to skip a few steps, but for now, just try to attack this thing kind of little bit by little bit. It makes them pretty easy to work with, but you just got to be really careful with all these little T's and F's and things like that. Okay, so let's go ahead and try to see if we can identify the truthfulness of P implies Q. That is a conditional. We know the only time that that thing is going to be false is if my hypothesis is true and my conclusion is false. So that second one right there, that's going to pick up a false, and all other times it's going to be true. The negation of Q is pretty easy. You're just going to flip all of these things on the Q column. So I'm going to have a false, a true, a false, and a true. Next, we're going to look at P implies Q and not Q. So I'm going to be comparing these two things, and I want to see when do they both happen to kick out a true, because I do have an and in this case. So you can see that in this case, I have only one T, so I'm going to have a false here. Likewise, I only have one T here, so there's going to be a false there. Same thing here. And at the very end, I'm going to have both T's occurring, which does happen to give me a true. This is actually really similar to the one that we were looking at back kind of when we were first talking about this definition of something that's always true. We looked at something very similar, except for in the middle of those things, I had this or. And in that case, we did see that this statement kicked out a kind of column of all T's because I just needed one of those things to have a T. Where in this case, I needed both things to have a T. So I'm actually only going to have one truth in this case, and it's going to happen at that very bottom. Okay, so next is I'm going to try to compare this thing with this not P, and that's going to be connected with this conditional. I'm going to go ahead and just create a column of not P because it's easy to work with when I have them all kind of next to each other. So what I'm going to be looking at is this column of P, and I'm going to flip all of those as well. So what started off with TT is now going to be false, false, and then I'm going to have a TT at the end. Okay, so now I'm going to look at this gigantic big conditional statement. I'm going to have this part right here, which is actually that column right there. That becomes my hypothesis, and then over here, this column is going to become my conclusion, this not P. Well, half of it, or 3/4 of the work, is actually really easy because you can see I have this conditional, and if ever I have the situation that my hypothesis is false, I know that this big overall conditional is going to end up being true. So in the first 3 rows, I'm actually going to have T's, regardless of what that second column is actually doing. The one time it actually matters to see what that second column is doing, both things happen to be true, so I'm going to have a true implies true, which is saying that that overall conditional is in fact going to be true. So in this case, you can see that I have trues all the way across, so this thing is in fact going to be a tautology. So we've kind of seen 3 examples of tautologies. Let's start to see some things that happen to not be those. Okay, next up we're going to have a biconditional. You can see that that double-headed arrow is in the middle of this thing, so it's going to read P and Q if and only if not Q or not P. So again, there's a lot of stuff going on in this thing. There is this and connected between P and Q, and then the other side of the spectrum I'm going to have the negations of both P and Q, but they're going to be separated by an or. So it's going to have the statement that this stuff over here has to occur exactly at the same time that this stuff over here is going to occur. So let's again try to dive into this thing with a kind of nice little truth table. I'm going to try to work inside out, or in a sense the left hand side and then the right hand side, and then compare them with this biconditional. So what I'm going to do is I'm going to first try to identify the truthfulness of P and Q. And then I'm going to try to do the other side of this thing. So first off, I'm going to try to find the negation of Q and then the negation of P, and then overall that or between those two things. Like I said, once you get kind of comfortable with these things, you might be able to skip one of those steps. You could probably create this column without having to create the two little columns. And then at the very end, I'm going to create this biconditional, this if and only if statement between these things. Okay, so let's go ahead and see if I can actually create what's going on in this case. So I'm going to look at P and Q, which is going to say I need both P and Q to be true for this thing to be true, which is only going to happen one time, and it's the very first case. All other times, I'm going to have at least one F, so it's going to be a whole bunch of falses. Okay, so the negation of Q, which is going to be negating this big column over here, which is going to say a false, a true, a false, and a true. The negation of P is going to be false, false, true, true. And then we're going to look at these two columns separated by an or. So I need to see when do I happen to pick up exactly kind of one T, or at least one T in this case. Not exactly, because it's just a classic or, not an XOR, I should say. So I need at least one T in this case, which happens here, it happens here, and it happens right there. The only time that that doesn't happen is at the very top in this case. So what's going to happen is I'm going to have a T occurring here, I'm going to have a T occurring here, and I'm going to have a T occurring there. And you can see here, it's exactly set up to kind of be bad in this case. I have a column that's got one T and a whole bunch of falses, and then the other column's going to have one false separated by a whole bunch of T's. Which when I look at this thing with a biconditional, which is this kind of if and only if, the only time that those things are going to pick up a true is if these two columns happen to have the exact same truth value. If you think about this biconditional is going to have to say that this thing over here implies this thing over there, which doesn't happen, but I'd also have to have the other direction occurring as well. So in this case, the false does imply this true, but the other direction doesn't work. So it fails this if and only if condition. So what's going to happen is that the truthfulness of the biconditional is going to occur when both columns happen to be the exact same. So if they're both true or if they're both false. In this case, there's always a mismatch. So a T and an F, and then the other ones are going to have F's and T's. So it's falses all the way across. So what that's saying is that it's saying that the left-hand side of this thing, this P and Q, they cannot occur at the exact same time that the negation of Q or the negation of P. And you're going to see a little bit later that there is a little bit more going on between these two things. This P and Q, the negation of that thing, is going to be connected to that other thing. It's one of these classic De Morgan's principles and these kind of equivalencies that we're going to see occur. But that's for the next chapter. We'll see a little bit more of kind of what's going on in that. But there's reason why this exact situation is actually kind of becoming bad. Why I'm actually having falses all the way across is because those two things actually are negations of each other. And you're not ever going to have those things perfectly match up because one is in fact the negation of the other. Okay, so let's look at one last kind of really big statement going on in this case. I'm going to have a situation that I have both P's, Q's, and R's, so it's going to be a very large truth table. It's going to have 8 total rows in this case, and I know that because each of those things have the potential to be true or false, and I actually have 3 statements going around. So in this case, 2 times 2 times 2 is going to multiply out to make an 8, so I do have 8 different possibilities floating around. The way that I'm going to attack this thing is, again, kind of working from the inside out, a little bit of left to right as well. So first I'm going to try to identify that not Q. Then I'm going to look at this P implies not Q. Then I'm going to try to look at this Q and R portion, and then I'm going to look at the negation of that thing, and at the very end I'm going to separate that thing by that OR operator. So it's kind of 5 little steps as you go along the way. So like I said, work inside out and a little bit of left to right, but they do become not so bad to work with. In this case, I do have 8 total rows floating around. So if I'm going to think about trying to do this separation of trues and falses, I'm going to have a whole bunch of T's initially, and then the other half of falses, and then I'm going to start to just divide by 2 as I go. So I'm going to have 4 T's, 4 falses, and then 2, 2, 2, 2, and then 1, 1, 1, 1, 1, 1, 1. Okay, so as long as you have that set up, it's not so bad to actually attack these things. They take a little bit of writing, but the actual process is not so bad. Okay, so let's go ahead and look at the negation of Q. So I'm going to take this column right here, this second column, and go ahead and negate it. So I'm going to have a false, a false, a true, a false, a true, and a true. Then I'm going to look at the statement P implies the negation of Q. So I'm going to look at that first column, which is going to become my hypothesis, and this is going to become my conclusion. Well, the easy part is when those are all falses, so I know that these are all going to kick out trues in the conditional world. And then all I need to do is I need to go ahead and see when do I kick out two trues. So a T implies T, that's going to be a true. A T implies T over here, which is going to be a true. And then the top two are actually in fact going to be false because I have a true statement is going to imply this false. And that's the one and only time that I do not have a true statement in one of these conditional worlds. So you can see that I have a whole bunch of T's and only two little F's floating around. Okay, next we're going to be looking at the statement of Q and R, which is going to say comparing those two things. In this case, it's going to kick out a true in the only case of when I have two trues occurring. So in this case, I have two trues there, and I got two trues there. All other cases, it's going to be false because I need both parts to be true. So I'm in fact going to kick out a true, and then a false, 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 and then a true, a false, false, and a false. And then I'm going to go ahead and just negate that column because I want the negation of that statement. So it's going to be a false, true, 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 a false, true, true, true. Okay, so in the very last little bit, I'm actually going to be attacking this thing with this classic OR operator. So what that's going to say is I'm going to pick up a true as long as I have at least one T. So in this case, you can see that the first one is I'm going to be comparing this column with this column, and I have a false and a false there. So I don't have any T's. So that's going to say that this statement right there is a false. Everything else, though, you can see that I'm going to pick up at least one T. Well, a whole bunch of these things are going to pick up a T over there, and the one that happens to be missing is over there. In some situations, I'm actually going to have multiple T's, but I need only at least one. So a whole bunch of T's are going to form below this thing then. So of the 8 possibilities of kind of the mixings of the truthfulnesses of P, Q, and R, it is going to be T or true most of the time. But there is this one very big false statement at the very top. And as long as I have at least one that's going to differ from the rest, this is not going to be a tautology, it's not going to be a contradiction, it is in fact neither. It's also referred to as a contingent statement in that the truthfulness of this overall statement is going to depend, or it's going to be contingent upon what the truthfulness of P, Q, and R happen to be.